backwards.
It doesn't matter. Just notes.
It does.
If we had our little, well, look over there, folks. There's our concept map. So we had parallelograms. Okay, I can't talk to you guys. A kite and a trapezoid, they're not parallelograms, so they don't have the same properties as a parallelogram. They're kind of their own thing. Yep. So let's label a few things on these pictures to help you remember them. So what makes a quadrilateral a trapezoid is it has just one pair of opposite sides parallel. So it would be like this side here and this one by those little arrows. And the big thing about a trapezoid are consecutive angles are supplementary. Fellas, thank you. Focus. These angles add to 180.
So each side is 180 or all four?
So it's all four would be 360, but like this guy and this guy. You guys remember what those would be called? What kind of angles? They are supplementary, but like from our special angle pairs. Consecutive interior. Yep. That's exactly what it is. Okay, like an isosceles triangle, an isosceles trapezoid has two legs. Two legs the same. So why don't you guys label this as a leg, this as a leg, and then the top and bottom are called bases. Some things to note about this is your diagonals are congruent, your legs are congruent, and then your base angles are the same. So this angle is the same as this angle. And then the ones on top, this guy up here, is the same as this one on top. Should we try some problems with these properties? Okay. Find the measure of angle K and M. So first off, isosceles or non-isosceles?
Non-isosceles.
Yeah, these aren't congruent. So we just know that those two angles have to add to 180. So what's 180 minus 87?
It's easy, that's obviously 93.
93. M is 93. Same thing for K and L. Have to add to 180. So what do we get, folks?
126. 129.
129. Beautiful. Okay, what's our game plan to find the measure of angle R?
You put them together.
That's it. Let's do it. These guys have to.
19x minus 10
All right.
equals 180.
I agree.
X equals 10. X equals 10.
Thank you, sir. You guys agree? All right. But now we got to plug in for R.
50.
So 70 minus 13 is indeed 57.
I like this math better.
Me too. Me too. Okay, we are told it's an isosceles trapezoid. What is DG congruent to? EF. Our legs are congruent. DF is congruent to what?
EG.
Because our diagonals are congruent. Yeah, it is. Your diagonals are the same. These guys are the same.
Oh no, that's parallel.
They're not, it's not a parallelogram.
Oh.
Not a parallelogram. Okay. So now we have an isosceles trapezoid. So what other angle is 47? Yeah, remember base angles are the same. 47. That's W. How can we find Y? Yeah, subtract from 180. 133. And if Y is 133, what is Z? Same thing.
But how could that happen? Because Y and Z are, shouldn't they be supplementary? No.
If these lines are parallel, but do you see how eventually these lines will touch?
Yeah.
No. Okay, good question. Great question. Okay, then we have this thing called a mid-segment. And your mid-segment connects the midpoints of your legs of your trapezoid. So what this is telling us is that all three of our bases and our mid-segment are all parallel. That's what's happening here. And then we have a nice little formula to figure out the length of it. So if we were looking for the length of EF, I'm just going to write it down here because I can't write very small. What we do is we take AB, add it to DC, divide by 2. So AB plus DC all over 2. Add your bases and divide by 2 to find the length of your mid-segment. So if we try this, if I wanted to find the length of my mid-segment, what do I do?
Top to the bottom.
Yeah, add our bases, divide by 2. 7 plus 11 is 18 divided by 2 is 9.
And you just count two.
Yeah, or you could count like what's between 7 and 11? 9. Sometimes it's not so obvious, though, but you sure could count. Ooh, what if we have the mid-segment but we're looking for a base?
You just count.
You could just count. What's the difference between these guys? 6. I need this to be the same. So where am I going to end up? 4. Counting's nicer. This next one is a challenge, though. We have to use the formula, right? There's no other way to do this. So we're going to take 38 plus x plus 14 over 2 is equal to our mid-segment. Okay, so we have x plus 14 plus 38 all over 2 is equal to our mid-segment. So if I simplify my top up here, what's 14 plus 38? Perfect. Now I'm going to get rid of my fraction too at the same time. So how do I do divide by 2? Yeah, multiply by 2. Those cancel. And now I take this whole thing times 2.
10x minus 38.
10x minus 38. Perfect. Bring my x's to one side, my numbers to the other. So we're going to have what? 11x.
9x.
You're right, 9x. Thank you, thank you. 38 plus 52 is 90. Okay, in a nutshell, that's properties of trapezoid. And then we have the goofiest shape of them all.
Kite.
A kite. They're just weird. Okay. Big ideas about a kite. This is what you need to remember. You have 2 pairs of legs that are congruent, so like your small guys are equal, and then your longer sides are equal. these two angles are congruent. These opposite angles right there. And then your diagonals are perpendicular, so these angles in here are 90. But what's kind of nice, though, about a kite is, do you guys see this triangle ABC and triangle CA? What do you notice about those two triangles? They're congruent. So it's really like, if you know all this information about this top guy, it's the exact same thing down here. It's just a big reflection. So that kind of makes it nice when you're solving for things. So let's try find these angle measures. All right. Let's start with the stuff in the middle. That's the easiest.
30 is 90.
Yep, because our diagonals are perpendicular, so all four of those are 90. Okay, what else would be 52?
1.
7.
Okay, it gets reflected up and down,
7.
right? So it'd be
1.
7.
It's 465.
52. 4 would be 65. And now we just have to subtract, right? From 180.
Minus 65 minus 90. So 1 and 2 are 25.
25 here.
180 minus 90. And then 5 and 6 are 38.
38.
So why are 1 and 2 25?
Because they're 25 plus 90 plus 65, so they need.
You have this triangle here, so subtract 90 and 65 from 180.
Why do we agree with 30?
Because 6 and 5 are the same.
Right, but where did 38 come in? I thought those two were
Because this angle is 52, so subtract 90 and 52 from 180 to get 38 right there. Last one. Find RZ, given that WX is 14 and WR is 8. How are we going to figure that out? Pythagorean theorem, but do I know what WZ is? What is it?
14.
Oh, good job. Okay. Out of these three, which one's my hypotenuse?
14.
Perfect. So we're going to have 8 squared plus x squared. That's it. I want to say it's 196, but I never remember 14.
Yeah.
Is it? Okay.
Is it?
So x squared equals 132,
Yes.
and I don't remember though. What that is.
I got 166, 196. 13.5.
No, it's going to be 12.
No, I'm right, you're wrong.
No, it's gonna be
14 times
11.
14 is 166.
Okay, actually, no,
it's
you're right.
11.5. Watch. I should use my phone then. 14 times 14. Yeah, 11.5.
11.5? Is that what the square root of?
You just
We don't know
said
yet.
it.
Oh, does anyone want to check it for me?
My phone is dead.
It's going to be less than 12, more than 11. I bet it's like 11.7.
I don't know.
6.
11.4.
What's the square root of
11.5. So 11.5?
Yeah. It's actually 11.4.
So we can round up
I
to
was rounding up
11.5.
in my head.
Sure.
Oh,
Shoot, where'd my pencil go?
Orange.
Oh my goodness, Bundy.
A worksheet?
Hold on. More on Pythagorean theorem.
Oh.
I'm done with it.
You're done with the Pythagorean theorem? Okay. Skip these problems on here, okay?
So skip 14, 16, 10, 12.
Yep. You're welcome. It looks like a lot, but the first one they're literally subtracting from 180. Don't fear. Don't get too nervous. No.
Skip 8,
You get to switch back.
So
What's that?
skip 6, 8, 10.
Yes. Skip those ones.
Oh, kites is 6.
Yeah.
Why?
Or you could do them with extra credit, I suppose. If you want to do all of it.
Extra credit.
You want to do extra credit? Sure.
Wait, so you can do all of them?
Sure.
Okay.
I'm doing that.
Oh, don't do 10? Did I miss
No,
something?
that's your credit. 16, 10, 12,
Oh, no. Just doing this.
Wait, on both? There's plenty on both seats. We skipped on one.
Nope. On the trapezoid, so the first page, skip 14, and then on the next page where it's the kites, 6, 8, 10.
Well, we can do those for extra credit.
Sure.
The next page is 16. I'm gonna try to do it all.
What?